The selection, the insertion, and the bubble sort are the three most basic algorithms for sorting. However, while they are basic, the tricky part is to understand the differences in between them. Therefore, in this episode, we are going to focus on each and see its delicate characteristics. What makes selection selection, and what makes insertion insertion, and what makes bubble sort bubble sort. Before we dive in, I would like to mention two key points about sorting algorithms. First, when we run sorting algorithms in CS, then we mainly discuss integers without any loss of generality, which means we don't care about the input, we assume it's integers. But we do not lose anything by assuming this, because we assume that we can transform any input, any item in the input array, into an integer. You get an array of characters, okay, each of them maps to an, let's say, ASCII character. Okay, so we don't have any issues with the input. We can assume it's integers or objects that contains integers. It does not really matter. The second key insight about sorting algorithms is that we can divide them into two main categories. One is comparison-based sorting algorithms, which includes the bubble, the selection, the insertion, the merge, and the quick sorts. The second is the non-comparison based sorting algorithms, which includes the counting sort and the radix sort. The key points about comparison-based sorting algorithms is that, yes, the lower bound of them is O of n log n, okay? However, we can cheat, because if you move from comparison-based sorting algorithms to non-comparison-based sorting algorithms, you can cheat and you can get away with the worst time case of O of n, a linear time, okay? So we have a way in standard sorting algorithms to move below the n log n. And this is the non-comparison, but this is not the topic of this episode. We discussed already the counting and the radix sort in previous episodes, if you want to refer to them. So we start with the bubble sort. The key point about bubble sort is that we start from index 0, and continuing the loop, we are going to continue and start from index 0. What we're doing is we look at two elements, 0, 1, okay, in elements in indexes 0 and 1, we compare them, and then we swap. If the right one is lower than the left one, then you move on to compare the next two elements until the end. What will happen is that the largest element would end up in the first loop at the rightmost place. So in the next loop, you can just go to n-2 index, however, you also start from 0, okay? So the key point is, in the bubble sort, we start from index 0. However, in each such internal nested loop iteration, we can go only one place to the left from the right side, because we already know that the largest items, because we did all these swaps, is on the rightmost place. Now to the selection sort and the insertion sort, the key differentiator is the left is moving to the right. Okay, so the left boundary is moving to the right. So in each outer loop, you increase the left by 1. And why is that? Because in the selection sort, we find the minimal item, okay? And because we find the minimal item and we swap it when we do the comparisons, then we can then assume that it resides on the left side. But then you could ask, okay, so what's the difference between the selection sort and the bubble sort if all we are doing is swaps in both? The difference is that in the selection sort you have like a pivot. Okay, the pivot is the current left. In the bubble sorts, we are moving both indexes to the right, so each time you do a swap, you see two consequent items being swapped. Okay, this is the bubbling. Okay, each time you see two consequent items, two close items one to another, and you swap them. In the selection sort, if you look at it visually, then what you see is that you pivot the left, let's say it's 0, so the left is the 0, and then you search, go with the additional index, with the second index over all the items. Okay, so one index is pivoted, it's rooted in single index, as opposed to the bubble sort where both indexes are moving along. So in the selection sort, one index is pivoted and the other one is moving along, and then it's doing the swaps again. So this is a commonality between the bubble and the selection sort. Both are doing the swaps. But the difference is that in the bubble sort, the swaps are for two consequent items, while in the selection sort, the swap is moving further from two consequent items. It's not two consequent items in the selection sort, because in the selection sort, you're focusing on selecting the item. This is why it's called selection sort. On the bubble sort, you are focused on bubbling up. If you need to bubble up something, that you need to take two bubbles and swap them, okay? Because this is how bubbling up works. Each time the bubble moves up, it moves up in between two items. In the selection sort, when you focus on selecting something, then I look at the left item, okay, I look at it, I focus on it, and then I have the other, like one eye is looking on the left item, the other eye, if you could do this with both your eyes, then the other eye is moving to the right and you are selecting one which is lower. Okay, so this was the differences between the selection and the bubble sort. Now, for the insertion sorts, it's a little bit different. The key differentiator of the insertion sorts as opposed to the bubble and the selection sort is that in the insertion sort, you're not doing swaps. The swaps are the world of bubble and selection sorts. In the insertion sort, you're doing shifts. Okay, so what you're doing is that, again, the commonality from insertion to selection sort is that the left, like if you focus your left eye to the left, so the left eye in each outer iteration moves to the right. Okay, so the left is moving as opposed to the bubble sort where the left is staying constant. So the left is moving in both selection and insertion sort. And what is happening is that each time you do a comparison in the insertion sort, you are replacing. You are look again, you focus again on a left. Okay, so again you are pivoting on the insertion sort on a certain item, but then you try to find the correct place for the current item. When you try to find the correct place, you compare, okay, two items, just like in bubble sort. But then you do not really do swaps. What you do is you take the current item like out. If it's out, this means you have a blank space. This is why you'll see that in the insertion sort, you put the current item that you're looking on. You each time in the iteration, you look at a certain item. You put it inside a variable. Once you place the current item inside the variable, you can put in this index any item you want because you saved it. This is why it's insertion, okay? You save the item in a variable and you find its correct place and then you insert it. While you're doing this insert, you will like shifting the array because each time you examine whether your current item is smaller than the item that you're comparing with, you move to the left. The canonical example is a deck of cards. You look at the deck of cards. Let's say I'm in the outer loop in index number 4. So I look at card at index number 4, I put it in a variable, so it's now out of the deck of cards, okay? Because it's in a variable. The variable is my hand holding this card externally, okay? So I remove this card, and then I look at each of the cards. If it's bigger than this card, then I'm moving this current card to the right, because I have a vacant place. I remove this card, I have a vacant place, until I find the correct place for this card. So these are the key differentiators in between the selection, the bubble, and the insertion sort. The insertion sort would be often linear time if the array is already sorted, because each time you look at the card, you see that you don't have any new place to insert it. And therefore, to sum up, we said that in sorting algorithms, we look at integers without loss of any generality. We have two kinds of sorting algorithms, the comparison and non-comparison based. In the non-comparison based sorting algorithms, we cheat. Okay, we have an OFN, a lower time bound, and then while the bubble, the selection, and the insertion sort all seem very simple. It's not the case. It's not the case that they are very simple because there are very delicate small items that differentiate each of them. The bubble and the selection are dealing with swaps. The selection and the insertion are moving the left boundary to the right, okay, while the bubble sort only bubbles things, so it's always comparing and swapping two items. And the insertion sort is not doing any swaps. The insertion sort is doing shifts. It's removing one item and then shifting the other items until it finds the correct place, just like in deck of cards. So I hope you enjoyed it. I sure did. I think these delicate differentiators between the so basic tree sorting algorithms are usually skipped. We usually tend to just describe each other, but it's very important to go through these differentiators and what makes each of the algorithms each. I hope you enjoyed this, and I will see you next time.